I'd like to get you started on worksheet 3, remembering the keys to solving quantitative force analysis. The instructions: determine the tension in each cable below. Draw a force diagram for the system before solving the problem. System, fancy word, means just the object, whatever we're going to make a force diagram for, whatever we're thinking of as the object, that's the system. So the object is the ball here. It's 5 kilograms. All right, so it's experiencing a gravitational force down. And it's being pulled by a cable, so there's a tension force upwards. So we are drawing a force diagram. Now we want to fill out as much as we can. It's 5 kilograms, but that's mass. That is not gravitational force. We have to get the gravitational force using this relationship. Gravitational force equals the mass times gravitational field strength. We can say that's 9.8 newtons per kilogram. So this gravitational force is 49 newtons downward. At this point, you might see that's what the tension force must equal because the object is in equilibrium. Forces must be balanced, and these are the only two forces. I want to show you how the net force equation gives you the same result. The sum of the forces in Y equals the tension force up plus the gravitational force down. Since it's in equilibrium, I know that's 0. Tension force, I'm pretending I don't know. Gravitational force, we just discovered, was 49 newtons, but it's downward, so you have to put the proper sign in. And now if we solve this for tension force, we bring the negative 49 over to the other side, making it a positive 49 newtons is the tension force. In the second one here, there's cable 1 and cable 2. It's okay in a force diagram to have two forces going in the same direction, so you really have a tension 1 and tension 2. So you can do something like that using a capital T and tension instead of F, and then I'll let you go from there and solve that. Question 2, we want to know the tension in each cable, and they're not numbered on your paper, but this cable between the ceiling and the 5 kilogram mass is cable 1, and then between the two masses is cable 2. Figure out the tension on each of those cables. Question 3 is really a trigonometry problem. We have to look at the situation and define a triangle that will allow you to use trig. Figure out the components, x and y, of that 38 Newton tension force at 55 degrees. Moving on, again, 4 is just a component calculation. So it asks for vertical and horizontal components. You'll do that. 5, it's phrased this way. It says, what is the rock's weight? How much of the rock's weight is parallel to the hill? That's just another way to ask what's the component of that angled force parallel to the hill. And then likewise perpendicular to the hill. So just components there. Same thing for 6, component calculations. Now 7, I think you'll have to figure out an unknown force. It asks you to write an equation for the vertical forces. That would be the net force equation, right? And an equation for horizontal forces, another net force equation. Calculating weight you should be able to do. And then use the net force equations to solve for the tension in the vine and the loincloth. All right, and then similar breakdown for the skier. It sort of asks you one thing at a time, and use what you've been taught to answer the questions and solve for the unknown. Good luck.